welcome Steve Teixeira.
Thank you very much.
Pleasure.
Wow, slides work and everything. Thank you very much for the warm welcome. Has everybody had a chance to have coffee, wake up? It's pretty early for developers, I know. We were just, it's funny, we were just talking about developer conferences in Germany. This is actually a little bit of a homecoming for me. I think it was 1998 or 1999. I spoke at a conference down the road in Merfelden called Entwickler. Years and years ago, I worked at Borland at the time. I was still doing developer tools. I've been doing developer tools for a long time. And so it's kind of nice to see some old friends in the crowd. It's, like I said, a little bit of a homecoming. My name's Steve Teixeira. I work on the Visual Studio team at Microsoft. Spend a lot of my time working on either the C++ IDE or the C++ product, as well as the core Visual Studio IDE that really encapsulates all the language features within the product. Wanted to first start with a big thank you to you guys. I don't know if you heard, we shipped Visual Studio last Wednesday. I don't think we timed this conference necessarily to try and land at the same time we shipped Visual Studio, but there it is. We shipped, and in fact, 72 SimShip partners. Some of you are probably in this room. So partners with whom we go to market with Visual Studio. We offer a side-by-side solution to customers. And since the pre-release, we've had over 600,000 downloads of Visual Studio. So just amazing, and thank you. Thank you for helping us make Visual Studio. I wanted to make a couple of announcements as well. And I'm here pushing buttons on my laptop when really they gave me one of these fancy things that I could probably use. So one of the things that I want to announce is, although we're just now shipping Visual Studio, we're already announcing the first update. A number of things that you'll find in the first update. One is some support for Agile teams. So within the premium and ultimate SKUs of Visual Studio, more support for Agile, more support in Team Foundation Server, continuous quality. So you'll see us continuing to release critical bug fixes, critical defect repair through this update vehicle. You'll see some new features around SharePoint development. And you'll see some new features as well around Windows development. I don't know, how many of you guys heard about this thing about targeting Windows XP? Anybody in the room targeting Windows XP from Visual Studio? We got a little feedback on that, it turns out. Some developers thought, hey, I wanted Visual Studio to be able to target Windows XP, both from the .NET side, and it can if you target .NET 4.0 framework or below, and also from C++, which isn't possible in the RTM version, but when we get update 1 out there, before the end of this year, you'll be able to finally target Windows XP as well. A couple other things that you can go get today. One is Visual Studio Express for desktop. So I'll talk about this a little bit in a moment, this idea that Windows 8 is kind of 2 operating systems in one. And we have an Express SKU, a free version of Visual Studio available for targeting Windows Store applications. And now we've also made available this new version of Visual Studio for targeting desktop, non-Windows Store style applications. And also, if you're an F# fan, any F# fans in the house? Don't be shy, F# fans. Where are you guys? I think there's maybe, no. All right, so what are we doing with Visual Studio 2012? We're trying to do a number of things and help developers on a number of dimensions. And just wanted to talk about Visual Studio for a few slides before we start talking about Windows 8. And one is this idea of supporting modern development. When I use Visual Studio, I should have an experience that represents the best of modern software development. And that means providing support for the latest tools. You'll find, for example, lots of great support for HTML5 and JavaScript in Visual Studio, as well as all the latest platforms. And so we'll have support for all the latest Microsoft platforms, including Windows 8. Phone is just around the corner, a bunch of new stuff happening with Azure, with SharePoint, with a new Office around the corner. So all the latest, newest support in Visual Studio is one of the things that you can expect from us. The other thing is support for a modern development lifecycle. Developers consistently evolving in terms of how they want to work. I want to work Agile. I want to do pair programming, what have you. We want to have that support within Visual Studio so that developers know when I acquire Visual Studio, it's going to support the way I want to work. And finally, the idea of continuous value. I talked about the first Visual Studio update just a few moments ago, and you'll see a continuous stream of these updates. We're aiming for every quarter some updates to Visual Studio to continuously keep quality high and continually add new features to the premium editions of the product. Now, when we talk about Visual Studio as the tool for Windows, there are a few different things I think about, and I kind of divide it into 4 buckets. One is the ability to build Windows Store applications, and that'll be the focus of what we'll talk about today. But also, you can continue to build desktop applications, just the same as you always have. Another thing that's new in this version of the product is the ability to build graphically intensive products. So rich support within Visual Studio for DirectX application building, for editing game artifacts, for building those kinds of games. And I'll touch on that a little bit. And finally, recognizing that software development is not just an exercise in writing code, but it's an end-to-end story. It's envisioning, it's building, it's testing, it's deployment, it's management, it's commerce on the back end, and then it's a full cycle around that. And Visual Studio will continue to embrace that, Visual Studio 2012, better than any previous release. So now let's talk a little bit about Windows 8. And I like to think of Windows 8 as the best of both worlds. With Windows 8, I've got kind of the same Windows that I know and love in terms of the desktop support. So generally, if you have something that works in Windows 7, if you have an app that works in Windows 7, you have some software that you're building that you target Windows 7, that stuff continues to move forward into Windows 8. Very high compatibility. At the same time, one of the things we're really, really excited about is this idea of Windows Store Apps, a reimagining of what the Windows user interface should be, what applications should be. For too long, I feel we've been caught in this keyboard, monitor, and mouse world where a developer's, or rather a user's experience with Windows or with a computer in general is kind of funneled through this idea of, well, we all kind of use the same keyboard, we use the same monitor, we use the same mouse. The Windows Store apps let us kind of break that mold, much more touch-aware. You can see us moving to a more gesture-based world with stuff that we're doing around Connect SDK, embracing more of the way, the evolution of how humans want to interact with machines, if you will. And Windows Store Apps, again, will be a focus of what we're talking about today. So just a quick show of hands. How many folks are running Windows 8 today? OK. And then by tomorrow, how many more left? Nobody else raised their hand. That was weird. So this shows you the idea here between the differences between the 2 styles of Windows. On the one hand, you've got the regular Windows that you know and love. On the bottom, you've got this new modern user interface, and I'll show you a little bit of that today, and the ability to build these store applications. So why do I care? What's in it for me as a developer and as a user for Windows 8? One, as I talked about, this modern user experience. It's fast, it's fluid. Things are pulled together with animations to kind of increase my emotional connection to what I'm doing. What I find really interesting, and I really thought the Windows folks got this right, is the ability to have a touch-first user interface where it makes total sense when I grab one of these tablets, I can start touching it and it feels right. But at the same time, it doesn't compromise the benefits of having a traditional keyboard, monitor, and mouse experience. So if I have a traditional experience, I don't have a touch screen, such as the laptop I'm using today, no touch screen, but it works really well through traditional user input. There's the Windows Store, which is great for both developers and for consumers. Finally, many of us remember how you used to acquire software by physically going to a software store and physically buying a box that was, if you were buying software developer tools, the box was probably, a meter long, and it probably weighed a lot. And you would, come and you would put floppy disk after floppy disk to install the computer. And man, we've evolved a ton since then. Now the Windows Store experience is integrated on every PC, and you as software developers have the ability to get the software you built in the faces of every Windows user, potentially throughout the world. Because there will be Windows Store experiences everywhere where people use Windows. If you're working in an enterprise, you also have the ability to sideload modern applications directly onto people's desktops without going through the Windows Store. So that's a great feature as well. Platforms and tools, I'll talk a ton about that today as we walk through Visual Studio 2012. And then support for new devices. ARM support is something we're very excited about, the ability to use Windows on battery-sipping, low-power devices with still great performance and provide a great experience, and continue to scale that same experience on up to x64 and x86. You'll also see a ton of innovation in the hardware space. Many of you might have seen Microsoft Surface, really interesting device that Microsoft is producing, tablet form factor with the keyboard. You're going to see from both Microsoft as well as our hardware partners, lots of innovation in this space as people are adding more sensors, as people are pushing the envelope for what it means to do great human-computer interaction. Now, I want to look at things from a developer-centric standpoint from this point forward. Many of you have seen this crazy block diagram of kind of what the Windows programming model looks like. I do this kind of impressionist artist version of this diagram, which looks like this. So that, let's say I'm building a Windows Store app or a desktop app. This kind of makes it clear, well, what can I use? If I'm a desktop app, pretty clear, I'm going to use Win32. If I'm a Windows Store app, I'm probably mostly going to use WinRT, but I may also be able to use some of Win32 because there are not modern equivalents of every Win32 API inside of WinRT. So I can use some Win32 APIs within my Windows Store style applications as well. Really, the focus of the conversation this morning, though, is going to be on this piece, this how do I build these Windows Store applications using WinRT. Now let's talk about how can I build these things? What are my choices? How can I build my Windows 8 UI? And we have a few different choices, and people come up with different ways to kind of talk about this. I like to simply break it down into three things. You have a choice between HTML5, JavaScript. The advantage of HTML5 JavaScript is it's getting to the point where that is the lingua franca of the user interface world. If you have a user interface that you can represent in HTML and add behavior to it through JavaScript, that's great, and you should do that because then the code that you write there, you can leverage on all the platforms you care about. You could take that and you could use it in web browsers, you can use it on iOS and Android devices, you can use it on Windows Phone devices, you can use it in Windows, you can literally use that code anywhere. And so where you have the ability to use HTML5 and JavaScript, you probably should. What we've done at Microsoft, if you look at some of the apps that we've built and that ship with Windows 8, many of them are built with HTML5 and JavaScript, and they use C++ components on the back end. So if I look at something like the Bing Maps app, mostly written in HTML, but they have some components for which performance is really sensitive and performance is key to user experience. And they write those in C++, and then they use WinRT to communicate at the language boundary. I'll talk a little bit more about WinRT in a moment. Second choice is XAML. Now, if you've been using Silverlight or you've been using WPF, you're familiar with XAML, a declarative way to express user interface. It's supported by all three of the major programming languages within Visual Studio, C#, VB, and C++. And C++ support, by the way, is new. It's the first time we've really had modern designer support for the C++ language. And leverages your existing, not just your existing XAML skills, but in many cases your existing XAML sources. And I'll touch on that a little bit more in a moment. And then if I have C++, I can also interoperate. I can have an application that's a combination of both DirectX and XAML. And finally, there's DirectX, which is the maximum power performance, probably the lowest in terms of productivity. It's not easy to do, but where you're building a AAA game title or frame rate is really key, or you want to have control over 3D models and meshes and those kinds of artifacts, sound output, etc., DirectX is definitely the way to go. DirectX, interestingly, is also the only way you can write a UI where you can build one code base, literally one code base, and take that code base to Windows, PC tablet. You could take that code base to Windows Phone 8, which also supports DirectX. And if you publish titles on Xbox, for example, you can take very much that same code and go publish that via Xbox as well. So DirectX, while it's more work, really does deliver on this promise of having one code base that I can use to target the breadth of Microsoft platforms. A little bit about technology paths, and this is kind of a, to me, this diagram reminds me of the London tube map or something like that. It's a little bit confusing, but the idea here is, okay, what if I'm a Windows 7 developer today? What do I go do? What technology should I pick up on? How should I evolve my application? What are my choices? And what I aim to do with this slide is kind of spell out where you should go and what you should do. So if I'm a WinForms developer in .NET, in Win 7, I can take my same code, my same skills, and I can keep doing that in Windows 8. Likewise, if I'm a XAML WPF developer, I can continue to do XAML and WPF development in Windows 8. Or, and you see the little green dotted arrow here up on the screen, I can also take those XAML skills and even some of my XAML code and go target WinRT with .NET XAML on Windows 8 Store apps. If I'm building Silverlight apps, HTML in the browser, I can continue to do Silverlight. I can continue to do HTML JavaScript in the browser. Or I also have the choice of taking my HTML JavaScript skills and delivering full application experiences outside the browser inside of Windows 8. Tons of controls available. So if I just look at the breadth, if I'm going to go build some Windows Store applications and what kind of controls are available to me, this is the stuff that's provided by default through third parties. You can get a bunch of other things, but it's kind of the the who's who of every kind of control you might be interested in using in an application. At least for basic behavior, buttons and radio buttons and combo boxes and web views and list boxes, grid views, list views, the ability to do semantic zoom in and out, navigation controls, sliders, progress bars, everything you would expect is there for Windows 8 user interface. And you'll see it all has a sort of flat, modern feel to it. So you're not going to see a lot of stylistic add-ons that don't add value to the user experience. So you won't see a lot of gradients. You won't see a lot of bevels. You won't see those kinds of user interface artifacts. Instead, what you'll see is pleasing flat views that don't distract the user from what they want to do, but really invite them to interact with the software. So I've talked a little bit about XAML and how your assets will carry forward. If you're building an existing desktop application and you would like to take that to the Windows 8 Store, you would like to make a modern Windows Store style application out of that, you can do that. In fact, you could take most of the business logic or maybe all of the business logic and move it forward, but you'll probably need to refactor the user interface so that you're building that user interface in HTML5 JavaScript, or you're building the user interface in XAML or in DirectX. Talking a little bit about desktop applications. Again, your existing investment in desktop applications continue to move forward. No real changes there. A ton of stuff that adds value if you're a desktop developer. Just core features of the IDE get better. New features in the .NET Framework 4.5 around asynchronicity. And I'll show you a little bit of that in just one moment. And in the C++ world, lots of performance benefits, the ability to do GPU development, et cetera, et cetera. So let's kind of jump in. Let's start looking at Visual Studio. OK, this looks like Visual Studio. So what I've got here is I've got a C# application. And let me just run it. This is a WPF application. Very simple. The idea here is I've got a customer care application. I'm working on the customer care phone line. Customer calls in with a problem. I'm the one responsible for helping the customer. So maybe they give me their customer ID. I can search for it. OK, there's my customer. And I can start interacting with my customer. I could say, OK, may I have your permission to obtain your previous and currently open tickets? Customer says yes. I can click that button, and it updates the user interface over here. Says, OK, the call started, got some permission. It's 9:07 in the morning. And I've got a responsive UI. You notice I can move things around. I can still type things. I can do all that. But asynchronously, it's fetching this list of all the previously open stuff. OK, so this was an application I had, targets .NET Framework 4.0. Works fine, as you can see here, running in Windows 8. But there are some things I can do to make this experience a little bit better in Windows 8. So for example, here's this code that when I click that obtain privacy or obtain permission button, you can see what it does. It does a few things. It adds some text to that text box, which you saw. Pretty straightforward there. It nulls out this list of tickets that I'm keeping. And then it does this update ticket list. Well, that one seems interesting. That's the asynchronous thing. So what does this do? If I look at the code for this, fairly straightforward again. I spin off a task using TPL, the task parallel library. So I start looking for tickets asynchronously. And then when the task is done, the continue with statement happens. And then I can go ahead and set is busy to false and do some housekeeping. And I can make sure that this thing gets run on the same thread as the UI. If I go look at this get tickets async, what does this function look like? Well, it just looks like this. What this does is essentially it creates a little proxy for the database that I'm accessing. And then it returns a result in the form of an iasync result, which is kind of a crufty, old-style way to do asynchronicity. In .NET Framework previous to version 4, I would use iasync results, which would kind of have this begin, end. Luckily, I now have this method called fromAsync, where I could take something that's an iasync result, and I can convert it into some task of T. In this case, I have a task of IEnumerable of tickets. So I've got this list of tickets that I'm managing. So I've got this get ticket async that I'm returning a task, and then I can then party on that task and obtain the results. So this is the .NET 4 version. Looks great, by the way, compared to what I would have done in, say, .NET 2, where doing this thing asynchronously, man, I would have spun up threads and dealt with semaphores or mutexes, and it would have gotten really crazy. So massive improvement here in the programming model. But in .NET 4.5 and Windows 8, it's a little bit better. So a couple of things I'll need to do, though. First, I would need to target a different version of the framework. So I'm just looking at the project options here. Let me target 4.5, and yes, I'm going to go ahead and make that change. And now that I've targeted version 4.5 of the framework, I can go ahead and I can use async. So let me first just comment out this .NET 4 implementation. And I bet you didn't know I did this, but I actually happen to have some code with me already that I could use. This is a .NET 4.5 equivalent, actually completely equivalent code. From a machine code standpoint, the machine code looks almost identical here in terms of what the compiler would generate. So some interesting things that you should see. One is I'm marking this method as async, as this operates asynchronously, and it uses the await keyword. Now, get tickets async, the fact that I use async in that method name is just kind of convention. When I have methods that return a task of T, I can call them blah, blah, blah async. And then the user of that method, it's a clue, it's a convention to the user of that method to know, OK, I can work with this thing asynchronously, and I can use the await keyword with it. So when I use await, what this does is it goes off and it calls this get tickets async function, and it sets up a continuation with the next line of code. So it won't go execute the next line of code until that asynchronous thing is returned. But meanwhile, while this thing is running, the application's still working, the application's still pumping messages. Everything continues to work as I hope it would. So if I obtain permission, and again, I don't have the blue swirly toilet bowl of death here, my application is very responsive. Actually, it looked a little faster. I think that was mainly because my database was hot that time. But just a much nicer programming model, fewer lines of code to express what is, on the back end, a fairly deep concept, but on the front end, something I should be able to do very easily in code. So let's talk a little bit more about building Windows Store apps. New designer support in the product. We now share the core architecture between Blend and the InVisual Studio XAML design experience. And I talked about WinRT. WinRT is a new application binary interface that you can kind of think of it as a modern version of COM. because underneath the hood, there's still an I unknown, there's still query interface, add ref and release. A lot of that stuff is still going on under the hood. But the way that we've projected WinRT into the Microsoft programming language stack is you don't have to know that's what's happening. So whether you're using JavaScript or VB or C# or C++, with C++, we've added some language features called C++ CX, and I'll touch briefly on that in a moment. But it shouldn't matter to you. It shouldn't matter to you what programming language you're doing. You can be a first-class citizen accessing the Windows APIs no matter what language you're using. So there's no like crazy P invoking, there's no like weird DLL loading stuff. It just feels like a natural part of the programming environment. So when I'm accessing HTML, I get a couple key benefits. One is I get, again, this single, consistent, platform-independent ability to express my user interface based on web standards, but at the same time, I have complete access to anything that surfaces as WinRT and projects as WinRT, including the Windows 8, much of the Windows 8 API. This relies, for its support, relies on WinJS, which is a Windows library for JavaScript support. So when I'm building Windows Store apps using JavaScript and HTML, this is the thing that gets pulled in to help me. I'll show you this in just a moment, but the idea here is I can use these standards-based methods to really build things that have a very high quality bar. They look professional. And I can use the integrated Visual Studio design tools as an experience. So I get to use Blend and the XAML style designers for these kinds of things. So let's just kind of go freeform a little bit in Visual Studio. So let's close out this solution. And let's just start something new. So we'll start a new project. I've selected JavaScript, Windows Store application here. And you can see I have a number of choices. So I've got some templates that I can use to get started. I can get started with a blank app. I can have something that presents as a grid. I can have something that kind of splits in two panes, fixed layout, something that's for navigation. So what I'm going to do is I'm just going to choose a grid application, and I'll just accept the default name. So it's building this thing for me. So now here I have already, I have a Windows Store application. So what are the key components here? Well, I've got this default.js file that has my core JavaScript in here. Not much, just a little boilerplate code. I've also got some default HTML. If I want to go look at this, I can say, oh, OK, well, here's my HTML. I can take that into Blend if I want to have a design experience around this HTML. I can mark up my, or style my HTML with cascading style sheets, and that's included by default. I can drill in here and look at my CSS. So we can see that in here. So pretty cool. Visual Studio is doing a ton in the background for me. So if I just go back to this JavaScript file, let's do something like set a breakpoint and then run. So here we go. I've set a breakpoint. I hit my breakpoint. So now here I am in Visual Studio. I'm running JavaScript. I'm running a Windows Store application. And I have just a regular developer-style app-building experience as if I were building a .NET app or a C++ app, but it's HTML and JavaScript. So what you might think of as traditional web technologies projected here is more of a client-building technology. I'm going to go ahead and run past this just so we can see the application. And there we have it. So there's my app. This is touch-friendly, although I don't have a touch screen, so I can paw at my laptop, and frustratingly, it does nothing for me. I can move things around, I can select, I can do all that kind of interesting stuff, and that's all kind of built into the default for me. I can get rid of this thing and go back. So that's neat, but as I mentioned, Steve Ballmer has not bought me my touchscreen laptop yet. I'm still waiting for him to do that. While I'm waiting for Steve, what I can do is I can use the local simulator. I could say, well, what if I were running this on a tablet? I can simulate a tablet, and here's where I'm going to just go ahead and hope that the demo gods are with me, because when I was doing this earlier, my tablet wasn't necessarily behaving, or my simulator wasn't necessarily behaving. So here's the simulator, and it's trying to start itself up. You can see that it's kind of a remote desktop-style experience inside of here. So here's my application. The demo gods are with me today, praise be. I've got this. It looks just like a tablet. I can do sensor stuff with it, too. So I can change the resolution if I want to try, what does this look like on a 27-inch screen? Wouldn't it be cool to have a 27-inch tablet would just carry around in your pocket. That would be pretty cool. I want one of those. I'll let Balmer know. I can set location, so if I want to try location-based services. So these are all the things that if you're building an app like on your crufty old laptop or on your old PC, you don't have this brand new hardware to mess with, well, you can use a simulator, and it works pretty well. I can also go ahead and select the little finger guy here, and now my mouse works like a finger where I can touch it. So the little circle looks like a finger. I can even do some of the gestures here. So if I swipe my finger from the side edge of the screen over, I can bring up the charms menu. I can swipe downward, and this will cause the application to close. Really, this is kind of a VM-style experience. So I've got my application literally running inside of here. Let me see if I can run this guy again. There we go. So application's running. Let me go back over to Visual Studio while this guy is running, and I'll set my mouse cursor back. So some of the other neat things going on is I've got this DOM Explorer that while my application is running, let me move over a little bit so we can see better. While my application is running, I can see what's going on inside of the DOM model that has been built around my HTML and JavaScript. And I can look at styles. I can look at what the layout is in terms of margins and padding and borders, and I can change borders and change widths between borders. And this all affects the cascading style sheets that are actually being used to run this application. So it's actually pretty neat stuff going on here in terms of what Visual Studio is giving me. If I want to go select element, I can come over here and say, hey, what element is this? OK, this is the element called group title 1. What if I wanted to just change this while I was in the middle of running? So what if I wanted to call this group BASTA, and then went back, and there it is. You can see it changes it in real time. So because this is just HTML and JavaScript, I have the ability to kind of change this stuff on the fly, and it works pretty quickly and pretty easily. OK, so let's close this guy. I love that gesture, by the way. Very, very, very handy. And then we'll shut down our emulator. All right. Now, there's also XAML. I talked a little bit about XAML. I talked about preserving your existing investments in XAML. We looked at some of the project types that we had for HTML around grids and navigation apps and fixed form factor apps. You can do much the same thing in XAML. And XAML allows you to think deeply about, OK, well, how are people going to use my software in portrait mode? How are they going to use it in landscape mode? What should my behavior be on rotation? All the Windows Store apps kind of have this built-in sort of page-based navigation model that I can use to transition through. How many folks have done XAML development just in the room? Let me get a show of hands. Maybe quarter of the audience, I would say, has done it. So in terms of XAML, one of the great things about XAML, I was a huge fan of XAML early on and still am. And one of the things I like best about XAML is it used to be that the way developers and designers collaborated is a designer would draw a picture of something, like in Photoshop. And then they would give this picture of something to the developer, and they would go, dude, make that. And the developer would go, you can't even do that. Like, what do you mean make that? Like, and there would be this, back and forth conversation about compromising this and doing that. And wow, this thing doesn't, the implementation cost you blah, 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 right? What XAML does is XAML allows designers and developers, sometimes who are the same person, but they can be different people, and they can collaborate on the same set of artifacts. They can have one set of files that they share with each other, and the designers can actually be more involved in terms of the building of user interface and building of the source artifacts that developers will consume and add the behavior to. We've got a couple ways to do XAML editing. One is an experience outside of Visual Studio using Blend, where if you want to go deep, you want to do animation transitions, all that kind of stuff, Blend is really great for that. There's also an NVS experience for XAML design, which if you just need the basics for kind of form building, that's all built into Visual Studio. And I showed you the set of controls that were available for XAML and for HTML, JavaScript, rich set that's there for you to use. Now, the key of XAML is to be able to connect that user interface to the code. And so what does that is the ability to create these ties. So when I declare the XAML, or when I write the XAML with this button, top line of code here, I've got this button, I can click it. If I'm using C++, for example, and I'll do a little bit of C++, and I promise, I know this isn't like big C++ conference, so I'll show you some C++, but I promise none of it's scary. And none of it's like evil, because C++ can get evil. So the generated C++ is like, great, there's this class, and it has these properties, and I could set the values of these properties, and it's got this on-click handler that I can go ahead and write some code for. I can also do data binding between my code and the XAML. So this shows an example of that, where I've got a class that has the bindable attribute, and it also has this public property called title. In my XAML, I can use the binding tag with curly braces and use that same name of the property that will create the connection between these two things. And I'll show you how this works in just a moment. But the idea that I can bind declaratively some piece of user interface to some source of data, a list or just a data member or whatever, and I don't have to do crazy stuff like manually fill up the contents of list boxes or grids or whatever. It just happens automatically through data binding. Again, if I've got existing XAML that I've done in VB or C# for Windows 7 or for Visual Studio 2010, I can continue to use not just the concepts, but actually much of the code. A lot of the stuff is directly applicable, how data binding works, how user controls work. There's a bunch of UI that I can keep, like buttons and stack panels and grids and things like that. So high value for moving those things over to be Windows 8 Store apps. So let's show a little bit of this, and I'll switch over to C++ here. So first of all, let me just close out this solution, and let me show you. So when I want to create a project, and it could be C#, it could be C++, it doesn't really matter. Again, blank app, grid app, et cetera, it's all there. There it is for C#, here it is for C++, kind of a bunch of the same stuff. You notice in C++, I also have the DirectX stuff there for me as well. So here's my project. Let me go ahead and open one that I have that I've created earlier to make it a little bit simpler. So I've created this application that I call XAML Face Finder. The way this application works is I can go select some images, and then my software will go find the faces within those images, and it will create new images that are just the faces of those images, and then I can do whatever I want with those kinds of things. I've started with kind of a boilerplate application here just because it's a little bit easier. So, for example, I've got some like file lists of input files and face lists and things like that. Let me go ahead and do a couple things here, though. I've got, if I run this guy just to show you what it looks like, simple XAML application, not much to it. Let me head back and let me go close this thing. So it does have a load button down at the bottom, and when that load button gets clicked, I want something to happen. Rather than type everything in real time, I've got some snippets set up that I can use to load this thing. And so what this does is, let me just walk you through this code really quickly. What this does is come up to my top of my load button handler. Here it is. So I open up the file picker. I say, OK, set some properties. I want to set it to start at this location, and I want to show thumbnails, and then create a task that go ahead and loads these files asynchronously as I've chosen them, adds the copied files to a list, and then also adds it to this input file list that I'm going to use later. The other thing I want to do here is I want to edit the grid view that I have here. So here's my XAML for my application. This is the editor. This is the grid inside the editor. Within this grid, I've got, let me show it to you. I've got one grid view here. And the grid view is for the top of this thing that shows the images I've selected. I just want to put another grid view in here to show the face-detected images on the bottom. And I have a little bit of that set aside. Let me just grab that snippet of XAML, and then I'll walk you through it really quick. So here's the snippet of XAML that I'm going to go use. And let's paste that into Visual Studio right after this grid view. OK, so what I've done here is a couple things. I've got another grid view. I call it the face grid view. You notice I'm using data binding to bind it to this list of files. So I've got that in there. And yeah, that's pretty good. I've got another data binding so that each element in the grid view binds to a specific image within this list of files. So things are going OK. The only other thing I need to do here is I need to add a reference to a library. See, I'm not a really good computational graphics person, but I'm really good at searching the web. And when I search the web, it turns out that there's a library out there called OpenCV that does face detection for me. So I went out, searched the web, I wrapped that with the WinRT wrapper. I'm going to go ahead and consume that SDK. And then, so let me see what I've got here. Now I've got another button that I've put in the app bar at the bottom that I use to detect those faces. So let me go ahead and put a little code in here so that when I push the detect button, I can go now call out, look at my list of images, call out to this library and say, hey, find the faces in those images and then show me the faces. This is the detect button here, and just a few lines of code here to show you. One is to clear out this list of faces, and then I create an instance of this face detect component, which is this WinRT wrapper for the OpenCV component that I got through my hard Bing Google engineering here. And then I set up an asynchronous action to go for each of these images. I go do the face detection. As I detect the faces, I add them to the list. And then when all of this is done, I don't exit this method here. That's what this line of code does. Until all these things are done, I don't exit this method. So let's see if this thing flies. And of course, because I'm using C++ code in this case, it's time for us to go on a coffee break because we're compiling. But the compiler's faster now than it's been in the past, so coffee break over. All right, so let's go ahead and select some images. We'll load some photos. How about we take Friends and Beckham? Those look interesting. So there's David Beckham. And then we're going to click that Detect Faces. This is going to be the thing that calls out to this library that I imported and looks for the faces of all the humans. So interesting, it found a bunch of faces for me. That was pretty cool. It created a bunch of thumbnail images of those faces. I noticed it found David's face, and it found 5 of the 6 friends. Apparently, Chandler Bing is a robot. I don't know what, but apparently he's not human. Computers don't lie. I'm sorry, that's just how it works. I could also do interesting stuff. Let's see if I can load photos from my webcam here. Let's see if this works. Kind of, demoing without say hi. Okay, there's me. We'll say okay. That's not a very good picture of me. It looks like my driver's license, actually. So there's me. Let's see if it'll detect my face. Ah, I'm human, and something behind me is also human, which is an interesting thing. I thought that was a robot, but apparently not. They're working on the algorithm to perfect it. And then that's the core of really what I wanted to show you with this particular with this particular application. With that, I just kind of like to summarize. Let me head over to my summary. Just kind of like to summarize things up in terms of all of your existing software, still good. Everything that ran on Win 7, things that worked on Visual Studio 2010, still good. Windows Store Apps, a new opportunity for you, particularly if you build software for a living. It's access, I think Steve Ballmer gave some gaudy number like 400 million devices running Windows 8 operating systems. Like, that's a huge opportunity if you sell software for a living. And Microsoft will handle the pipe for you to get your app out in front of people that may be willing to pay for it. You can choose how you want to develop for Windows Store. So if you like .NET, you like C#VB, you can continue to do that. If you want to use the advantages of HTML, JavaScript, you can do that. If you need the power and performance of C++, you can do that too. DirectX, XAML, whatever. And Visual Studio is the thing that provides the tools you need to go do that. And with that, please enjoy the conference. Thank you for hosting me here. Look forward to meeting some of you during the conference. Thank you.